the massive increase of signups that it couldn't handle. Another thing is that Bitcoin had been highly associated with illicit activities, and it has been used for things like money laundering, scamming, and maybe even terror financing. Also, it is the payment method of choice for cyber extortion. I hope we all heard about cases of WannaCry 2.0 or NotPetya last summer that hit real large corporations such as Telefonica, Deutsche Bank, and Maersk, causing millions and millions in losses. Thievery, systems being hacked and funds being stolen, like the famous case of Mt. Gox. And the most notorious use case would be the trading of illegal goods in the darknet markets. And finally, the characteristics of this technology kind of create certain needs. One of them is that businesses that interact with Bitcoin, they have to comply with AML, anti-money laundering, and KYC, know your customer rules. So they need tools that will help them assess to what extent funds have been involved with the previous activities. And so they can actually report due diligence with, in the case of US, the SEC. Another case is that law enforcement would need tools that will help them trace the origin and the destination of the funds, so they can collect more information about whatever suspects they're investigating. So the main issue, if I have to summarize that in one sentence, would be that Bitcoin is a pseudonymous. Pseudonymous in comparison to traditional electronic payment methods, where a centralized organization, for example, a bank, would collect data about the person who's requesting this account. For example, a bank will ask you for your ID, will ask you for a proof of address, and then it will create an account for you. But in the case of Bitcoin, anyone can create an account at any time. And there's no real need to provide any kind of linkable or identity information of the user. The question we want to answer in this research was, is it possible to predict the category of an unknown cluster on a Bitcoin blockchain? And in this case, using supervised machine learning. So before starting with the methodology, here is a refresher of some basic concepts. In a simplified way, this is how a Bitcoin transaction looks like, where we have X that is sending one Bitcoin to Y, and X has an address that looks like this, a 34-character string, and this is Y represented by another address. And this is all we see if we look at sources of data such as block explorers, and we try to trace funds. But in reality, X is actually, it should look more like this, where X is actually Alice that has a wallet for a personal use. And Alice doesn't have only one address, she has many addresses. And Y is actually Kraken, is an exchange. And this kind of vocabulary is the one we're using for the paper and this presentation, where we define a cluster as a group of addresses that is controlled by one entity. And one entity has a category, which is defined by the activity. In this case, Alice would be the name of the entity, and the category will be personal wallet. And in the case of Kraken is the name of the entity, and category will be exchange. So this is, again, in a simplified manner, how the Bitcoin network looks like today, where each of these dots are individual addresses, and they're sending each other transactions. And the data provider, Chainalysis, has been doing is it would take this cloud of gray dots and turn it into something more like this, where the circles are larger, meaning that there are more addresses in the same cluster, and the colors indicate the categories, so the activity of this cluster. And actually, this is the starting point of our research. The data provider has already clustered a portion of the ecosystem, and it constitutes our initial data set. So initial data set is the observations are clusters, groups of addresses across 10 categories, including legitimate services and not so legitimate services. This is why we chose to use supervised learning, because we already have a data set of labeled observations And we can just feed this to a model which can learn and predict the label of the gray dots that we showed in the first cloud of dots. Okay, so similar to an experiment involving big data, there was a data preparation step. The raw data is public. Actually, anyone can become a node to this network, and you can simply use the Bitcoin Core data APIs to download the entire Bitcoin history. But the data provider has taken this raw data and applied some clustering algorithms and some heuristics, for example, co-span heuristics. And then we take this enriched data and we clean it because models, for example, don't deal with null values. Hello? Is everything fine? Okay, I'll just continue then. So we take this data, we clean it, and then based on the domain knowledge, we engineer a bunch of features, in total 76 features, which compress all the transactions that each cluster has into one row. And at the end, we have a matrix of 434 rows and 77 columns. The last column would be the label. Different algorithms, KNN, random forest. My internet connection is unstable. Now, is it better? Can anyone sign me? Anyways, okay, so.
Yeah, we can hear you.
You can hear me, okay, all good, thank you. So we take all these algorithms such as KNN, random forest, extremely randomized forest, back decision trees, gradient boosted trees, and then just with the 4 parameters that scikit-learn offers, we train all of them, and then we check the results. And the purpose of this is that we can make a previous selection of what kind of models are more suitable for the problem. And those were, at the end of this iteration, those happen to be random forests, back decision trees, and gradient boosted trees. Now, in the second iteration, we apply, in the second iteration, we take the metrics once again, and then we take those 3 models and then train them a lot, many times using cross-validation random search to find those sets of hyperparameters that give the highest confidence score. And then we check the results. In this case, the one that was, the conclusion was that the best performing model was gradient boosted trees. So we take gradient boosted trees and then we start with the 3rd iteration. And in the 3rd iteration, we apply a technique called SMOTI to synthetically increase the samples of classes that are very undersampled in comparison. In fact, in this one plot, you can see that the classes like exchange have a lot more dots than the classes of hosted wallets, mix, and services. So we take SMOTI and then we try to oversample those 2 categories in particular to try to find this class imbalance. Okay, so we apply SMOTI and then we repeat the hyperparameter step. And this time we only use gradient boosted trees. So we find out that the highest confidence score is actually with this model. So here are the final results where the most suitable algorithm was gradient boosted trees, and it provided an average confidence score of 77%. So with this, we can answer our research question of it is actually possible to categorize unknown clusters on Bitcoin using supervised learning. With this research, we challenge once more the true level of anonymity of the Bitcoin blockchain. And with this process, we kind of prototype the tool that can be leveraged for compliance in the case of businesses and for investigation, for crime investigation in the case of law enforcement. However, there are some limitations that we need to consider for future research. And the first one is the data set limitation, which is we only have 434 observations. And as we saw, some categories are heavily undersampled in comparison. And even if we apply techniques like SMOTI to mitigate it, I would say that with every extra step, we also introduce more bias to the problem. And then another thing, is that there was data that was not used that is actually available. Those things are, for example, the number of signatures per transaction, IP addresses, the type of addresses. And finally, also due to the data set limitations, we didn't have a test set. In conclusion, our goal was to predict the category of unknown clusters on the Bitcoin blockchain. For that, we used data set of already identified clusters, and after 3 iteration process, we concluded that it is possible to apply this methodology. And we using gradient boosted trees. It provides an average confidence score of 77%. So these results imply that this method can also de-anonymize the network to an extent. And considering all the limitations, it just paves the way for future research. As for future research, starting with expanding the dataset of identified clusters, not only with more observation, but also more categories. Redefining the methodology by applying automatic feature engineering in contrast to the manual process which we used in this paper. Maybe test a wider range of algorithms in comparison to the 7 we have, or even transform the problem into a binary classification opposed to multi-class, which is the current one. And then finally, a logical step will be to take this model and apply it to prototype the industry and uncover a larger portion of the network for different purposes. This last step will lead us to another paper, which I presented last December in Boston in the IEEE workshop in cybercrime. In this research, I took a model and then I predicted 100,000 uncategorized clusters. And then by plotting the results, we reached to this pie chart. So what I'm aiming at for this is that all of a sudden with this, we have an overview of what you can find in the ecosystem and how much of it. Because before this, we will hear, I often heard the sentence of Bitcoin is only used for buying drugs. But before these charts, there was actually no numbers backing this kind of claims up. All right, so yes, this is the end of my presentation. Thank you for listening up to now, and we will now open to questions. I don't know how we're doing the time.
I see there are a couple of questions for you in the chat.
Okay.
From somebody called France. Somebody called France Still is asking a couple of questions. How many different categories are there today? Can a category be dynamically created by a user?
Let me see. So right now there are 10 at the point of this research. This is likely to be more because the data provider kind of focuses on the categories that are cybercrime related. If it can be created dynamically by the users, you mean using this tool? Whoever asked the question. So category.
It was France Still.
Sorry?
It was France Still. He's saying no, just in general.
If categories can be created by the user. No. So this data provides is coming from Chainalysis, and they are the ones creating the categories. So they will for example, analyze something and they'll see that this is coming from exchange, then they will label it. But there's no end users of Bitcoin are not using Chainalysis tools. So they will not be able to create their own categories, let's say. But if the question is, if you as a user of Chainalysis tools can create your own categories, then this is something that I like to take out of this call, because this is about, I would probably put you in touch with somebody from Chainalysis who's dealing with this kind of conversations.
There's another question for you from Jim.
Mm-hmm.
He says, any law enforcement organizations you are working with?
This is confidential. I cannot answer.
Okay. Okay. Anybody else with questions? It looks like there are no. I don't see any in the chat.
So
is it possible to get a copy of the slides, or they are posted
The
somewhere?
slides are public already on the website.
Okay.
So on the CSIG website within the chat, and we can repaste it again now. Let me do that. So you can get them. You can download them now.
okay. More questions, maybe? We have time, right? When was this supposed to be over?
Yeah, we have another few minutes for questions.
Okay.
So, oh yes, I see another one. How many observations do you think you need to get accuracy?
I think that there's no way of knowing really. So okay, there's more to this. This paper was presented in January, and after that I made a bunch of other iterations with similar problem with increased data set. And in those cases I used so in this paper I used the training set was something around 900 observations, and the accuracy was increased about around 5%. So there's already a major increase in that sense. But I don't know. I wouldn't know. The more the merrier, because you need to get the more data you have available. You have to use You should use everything, so your model doesn't overfit. But I can't estimate upfront how much data I would need for the model to perform. Like the whole experience is about trying and testing. So yeah, to answer your question, I wouldn't know. I would if I had access, if I could choose, I would choose all of it. Is there more questions? Is that I see something.
I don't see any more questions. I see one or two people have unmuted themselves.
Okay.
Or I see some thank yous, great presentation. Oh, here we go. Is an observation equal to a BTC transaction? From Joe.
Okay, so a observation is a bunch of. It can be from one transaction to hundreds of millions of transactions. One observation is a cluster, and a cluster is a group of addresses, and that address might have from 1 to n transactions.
Another question. Is this dependent on the randomization of the category tag by a particular service?
On the randomization? I would need more specifics on this.
Franz, do you want me? Can you unmute yourself, or shall I unmute you?
Yes.
Here we go, Franz.
Yeah, can you hear me okay? This is Franz. Yeah, I was wondering whether I saw those tags look like a bunch of, random data, basically, random tag of some sort. I just wondered, does it depend upon the Bitcoin or blockchain service that's being used as to what the randomization scheme was to produce that tag? Hello?
Oh, hello. Am I back?
Yes, you're back now.
I was asking, are you referring to these 10 tags here? Where they come from?
Yes, that's what I was referring to. In other words, that's somehow being transmitted or used by the service involved. And I'm just wondering whether that depends upon how they randomize those.
So these tags are not randomized. These tags and observations are actual services that exist in Bitcoin or have existed. So for example, in the case of exchanges, they are public services. So you can find the names by Googling, for example, Bitcoin exchange.
Okay. So again, if are these standard tags that exist out there that are well known and they're public? Exactly. Okay.
Some of them not that public though. Some of them, for example, ransomwares
Right.
have to be public because of the payment schemes.
Right.
Scams are public but are tricking you to something else, right?
Mhm. Are there other aspects of the messages themselves, like their size or other aspects that you could use to determine whether or not it's let's say an exchange interaction or some other interaction?
So we did try to represent a behavior or the characteristic of an entity, and by that we try to get, for example, certain statistics. This is in the part of the features. We try to, for example, get measures like how much a certain service has interacted with other services. And then if you do the study and you dig into this kind of summary statistics, sometimes you can find some evidence of, for example, let me just go back, exchanges interact more with other exchanges, or like ransomwares or illicit activities interact a lot more with dark core markets. But I'm just like speculating right now. I don't have numbers to show.
Okay, good.
But you
Great.
could do this kind of.
Thanks very much. Great job, by the way. Good.
Thank you.
Any more questions? It seems like there are no more questions, so we can. Thank you so much.
Thank you guys for having me. Thank you for organizing. And then please, if you come up with further questions after this, just really email me or use my Twitter handler. If you email me, encrypt your message. You can find my PGP key in my website.
And also, Jim has just posted a great Medium article by you in the chat.
Interesting.
It was yours.
ICO bubble one, is that yours? I think.
Sorry, which one is it? Let me just scroll down.
ICO is a bubble.
Oh yeah, yes. I wrote this long time ago, and long time I mean last summer. But everything has changed so much.
Yeah.
It was an event by Hyperledger, which is a project by IBM, right?
That's correct.
Mm-hmm.
Yeah. Good job. Thanks.
Yeah, thank you. Thank you so much.
Thank you, Ella.
And congratulations again on the Hicks Award for Best Paper. That's a great achievement as well.
Thank you.
Thank you. Thank you, everybody. So I'm going to leave the chat open for a bit. You may want to stop recording, Jim, as well. I've stopped too.
Okay, I'll stop the recording. Thanks, everybody.
Yeah, and then we'll coordinate. And